Good afternoon, and welcome to today's Transmission and Distribution World webcast, Inside the Advanced Meter Fort Collins Project. Now, this presentation is the first of four webcasts focusing on one of the nation's most exciting and successful automation projects. And my name is Paul Malden. I am Executive Director or Editor of TDW World's Grid Optimization Center of Excellence. Before we begin, I'll explain how you can participate in today's presentation. First of all, if you have any technical difficulties during today's session, just press the yellow Help widget on the bottom of your screen to receive assistance. We welcome your questions during today's event, and so in order to submit your question to today's presenter, simply type your question into the question window on the left-hand side of your screen, and then hit the Submit button. We'll be answering as many questions as possible during the Q&A session that follows the main presentation, but please feel free to send in your questions at any time and we'll add them to the queue. Now, if at any time you're having audio difficulties or don't see the slides advance, just hit your F5 key on your keyboard to refresh your webcast console. Also, the logos you see on your console are hot linked. So if you want to visit the corresponding website during this webcast, you can click on any logo and a new window will open. This will not take you out of the webinar. Now let's get going. Today's featured presenter is Steve Katanak. Steve is the Light and Power Manager for the City of Fort Collins. We are also joined by Mike Carantha, Vice President of Elster Solutions. And Elster is the sponsor of today's webinar and is the chief sponsor of the TDW World Experience Station, which you can access at tdworld.com/AMFC. The Experience Station includes videos from Steve, Mike, and many other key stakeholders in the Advanced Meter Fort Collins project. So at this time, I'm going to hand things over to Mike to say a few opening words and introduce Steve's presentation. So take it away, Mike.
All right, thanks, Paul. Hi, my name is Mike Carantha. I'm with Elster, and I'm responsible for our sales marketing strategy in the North American market. First, I wanted to thank Paul, Brian, Tim, Rick Bush, and the whole T&D team for this fantastic webinar venue and the technology behind it. Obviously, there's a lot that goes into producing this, and I appreciate what they've done for us here. I'd also like to thank them for the T&D World Experience Station that focuses on providing resources and knowledge around a successful approach to a complex technology implementation. I hope you all take a look at that resource when you get a chance. And just a quick comment about Elster. We've been a strong proponent and an early technology provider to the smart city concept. Our view of this revolves around cities using technology to operate more efficiently and where they become more engaged with their consumers, providing more information made available where and when the consumer wants it. So leaving with you that, I'd like to introduce Steve Katanak, who is the Light and Power Manager for the City of Fort Collins. In this capacity, Steve is responsible for over 120 team members that provide construction, engineering, warehousing, meter reading, substation construction, and substation operation, all focused on keeping the lights on for the citizens of Fort Collins. Steve's been in the electric industry for more than 27 years, and he's worked as an electrical engineer for the past 29 years. He's got a BS degree from New Mexico State University, and that's got a focus on power engineering. Beyond all that, Steve has been the executive sponsor and the driving force behind a very interesting project called Advanced Meter Fort Collins, or sometimes referred to as AMFC. This is what you're on the webinar to hear about today, and I can't say that I've ever seen a project so well managed or expertly delivered as the Advanced Meter Fort Collins project implemented by Steve and his fantastic team. With that, I'll turn it over to Steve and let him tell you all about it.
Well, thank you very much, Mike. I appreciate those kind words, and I appreciate the recognition of the team that has really delivered on this. First off, let's take care of the little bit of legalese I have to do. So as a municipality, we partner with many vendors, and the City of Fort Collins, our procurement process strives to promote a fair and open market and allowing any business the opportunity to compete with us. That being said, we don't endorse or recommend any specific commercial product, process, service, or manufacturer. little bit about Fort Collins. It's a wonderful place to live, to work, and to play. We've been recognized nationally by many different awards, different magazines that have recognized a great place to retire, a great place to open a small business, and certainly one of the great places to sample a lot of different microbreweries. We are quite proud of our water, and as a result, we're quite proud of our beer. So the city itself is about 60 miles north of Denver, Colorado. It's home to Colorado State University, which has about 27,000 students, hence why we sell a lot of beer. We always joke about the fact that Fort Collins produces about 1 million gallons of beer a day, and some of that actually leaves the city. We're about 155,000 people in our population and cover an area of about 55 square miles. To get more specific to the project, let me start off with a little history and why this project originally started. The City of Fort Collins, being a municipally owned utility, one of the benefits we have is that we reflect the values of our community. And being a very educated and very green community, we have several policies and plans in place as a city government that help establish the direction we're going in the future. One of those is a climate action plan. The city has committed to reducing greenhouse gases by 20% below 2005 levels by 2020 and 80% by 2050. We also have conservative water conservation plans. We have an energy efficiency plan that sets some very aggressive energy efficiency goals for us, reduction of use on an annual basis of 1.5%, and also reduction of our peak demand by 5% by next year and 10% by 2020. We're also part of a project, an initiative called Fort Zed, that has established our downtown area as a zero-energy district. As time has gone by, Fort Zed has grown into more of zero-energy demonstrations, where we provide a platform for piloting new technologies and new ideas in how best to reach some of those climate and efficiency goals. The impetus for our project was actually, and I'm going to back up, sorry. The impetus for our project was actually the climate action plan. In 2008, the city adopted a plan, and in that plan, one of the strategies that they had identified was advanced metering as a use of educating and providing information to customers so they could make informed decisions about their energy usage. What the plan had really anticipated, though, was providing all of our customers with these units that plug into the electrical panel and provide some data directly to them. So when we started looking at that as an electric utility, the cost was very high and the benefit to the utility was pretty low. So we did a business case looking at the implementation of advanced metering infrastructure and what some of those costs and benefits would be. So at the beginning of 2009, we started developing a business case. And at that time, this was only looking at the implementation of a metering system. We weren't even considering a meter data management system, web portal, or any of the other technologies. So we went through and we identified specific benefits that we could achieve. Those included increased meter accuracy, reducing our meter reading expenses, water and electric theft and diversion, engineering costs could be diverted, and also cash flow advances. And what I mean by cash flow advances is if typically you are billing and spending 7 to 9 days till you can get that bill to the customer and collect those finances, there is a cash flow advance if you can reduce that timeline to 2 or 3 days. You've got the money quicker, and that is one of those benefits that we anticipated. We also anticipated some annual costs associated with the program, and that was software maintenance and support, of course, and utility full-time employee additions, which really encompassed, we knew at a minimum we would be adding a database administrator and system support to help keep our system running. So at that time, we went before our city council and we went through our budgeting process. And as a city government, our budget goes through 2 readings or 2 votes by city council before it's approved. So between the first and second vote, we were notified by the Department of Energy that we had been awarded a smart grid investment grant for our advanced metering project. So what we had done is we had a IT strategic plan that outlined all of those elements related to a smart grid that we anticipated doing over the course of the next 5 years. As we applied for the grant, we took the IT strategic plan information and combined that with our AMI system and put together a much larger project. That total project was a $36 million project. So what we did is applied for a SCIG grant and were awarded $16 million from the Department of Energy, which would cover the electric infrastructure, including MDM, meter data management systems, a web portal, mobile, some grid automation, and the management to deploy the systems that we had. Also, in addition to the DOE grant, the city also was paying $4 million to add communication modules to our water metering system. When we went through and did a payback analysis on the operational savings, that was about 11 years till the systems paid for themselves. So with that, we took a step back, organized around the much larger project, and began our meter installations in early 2012. Now, some of the project goals for us is we are a triple bottom line focused city, which means we take into account economic, social, and environmental impact of any project we do. So just in high generalities, the economic benefit was certainly we saw an opportunity to control our operational costs and our demand costs. Socially, this allows us to give customers much more information so they can make informed financial decisions about how they're using energy. And environmentally, this will help us meet our energy policy and climate action goals. Plus, we really see this as a foundational project that prepares us for the future. We have installed basically a communication system across the city, which will allow us to start to build. We're already looking at opportunities for some of our storm floodwater monitoring systems, utilizing our communications, and for other monitoring around the city. So as I noted before, the project elements really expanded from just AMI. I mean, it included the electric metering, water metering modules, but the communication infrastructure, an MDM, web portal, demand response, cybersecurity, which turned out to be an 800-pound gorilla. As part of the Smart Grid Investment Grant, we committed to implementing, at the time, CIP 4, I believe it was, may have been CIP 3, which is critical infrastructure protection. And one of the challenges we had was we were not prepared for the scale of cybersecurity implementation. The challenge was, as we brought in some consulting help to help us define what we were going to do, we realized that this component of the project was overwhelming. So we had an opportunity to leverage the strengths of a former chief information officer that worked with the city and to bring him in to help us design our cybersecurity policies, which I think really worked very, very well. One of the things we found as we have worked with the DOE in this implementation is they've developed several tools that are very useful in providing a recipe, a walkthrough process that you can really evaluate your systems and your utility without having to reinvent it. Part of what we felt we were doing is inventing our cybersecurity evaluation. So I think the opportunity has really matured in the ability to evaluate that cybersecurity and to implement some policies that help protect your system. Just a little bit about the communications I've talked about. The type of system we installed was a mesh network. What we looked at is, if we look at our utility network, we have, of course, our EAMS, which is energy access, our metering system, the head-end system. And then we have a Wi-Fi system that we've overlaid across the entire city that communicates with gatekeepers that they gather information from the meters, and the meters are all meshed so that if one is not communicating or you have an issue, it finds another path. We have found this system to be extremely reliable. We monitor daily what our percentage of delivery of data is. It's typically in the 99% range. We've had very, very few issues with the technology. I think it really helps to examine your area and to do specific designs around trees, around all of the challenges you may have. As we deployed, one of the biggest surprises for us, at least for me, I think my staff and our great team working on this probably anticipated it, meter routes. You can't just go out and wholesale replace a given area on a weekly basis. You have to take into account the meter routes, the billing periods that those customers fall within, and you have to really account for a blackout period. This created a challenging scheduling opportunity for all of us to learn about how to take a crew of meter installers, and you may have to shut them down in one area, move them to another while you sweep through the given areas. So one of the things I wanted to stress is we provided our customers with options. We had three different options. An option one customer is one that took the standard installation. Meter had full capability. The second option that we offered was for those customers that had concerns about privacy, that at 15-minute intervals we would be able to know something about them. So we developed option two, which provides one read per day, one data point per day, and on the water side provides 2 meter reads per day. We also had a manual read option. That's the option 3. For $11 a month, we would or will continue to send out a meter reader to read that account. Now, this worked out very, very well for managing our customers. The other thing we did is those customers that told us no, told us go away, I don't want it, whatever they may have said, what we fundamentally did is kick the can down to the end of the project. When we were wrapping this up, we had about 500 customers that had said no for whatever reason. At that point, what we did is we started making one-on-one calls to each of those customers to see if we could provide them with additional information, if we could answer any questions they may have. The intent was really to at least get them to pick option 1, 2, or 3. We really didn't care which, but we wanted to at least get their meter changed out from an analog to a digital. That was very, very effective. That brought it down to about 50 customers that were holding fast and did not want us to change their analog meter to a digital meter. So we had to get a little bit harder with those customers. Certainly the meter is owned by the utility. The city has the right to access, change, and to specify the equipment that it uses on its system. So we informed those customers that we would have the right to discontinue their service if we couldn't change their equipment. That brought us down to a final 9 customers that basically locked up and said, okay. And really of those, only 5 of them were electric meters. We ended up having to force the exchange of those last 5 meters from analog to digital meters. They were all option 3 customers. Not the most pleasant thing to do, but we do think the way we managed it by delaying all of the difficult customers to the end of the project so that it didn't create public issues for us, and then reaching out one-on-one with each of those customers were very effective ways of managing those customers. The other thing we did is in our education process, we wanted to come up with a simple way of communicating the relative risk. As you all know, there is some concern about RF emissions, radio frequency emissions from different devices, cell phones, and from the meters. So we developed this comparative chart, and really what this says is RF exposure compared to a 5-minute cell phone call. So this clearly helped us communicate to our community that the risk was really fairly minor. This is saying that if you stood in front of your meter for 68 days, that's equivalent to a 5-minute cell phone call. If you were 3 feet away from the meter, it would take 1.7 years to get that same level of exposure, and 19 years if you're 10 feet away. As I did presentations, and all of us did presentations around the community and around the country, what we found is this really rang well with customers. It really helped them understand the relative exposure and dismiss it in many instances. Customer information. Now, this has been part of the significant goal and what we have been trying to achieve. This is a screenshot of our web portal. The web portal will give monthly comparative data, daily comparative data, 15-minute data, and hourly data for the water information. And we have seen a continued increase in customers as we move forward. One of the interesting aspects that we didn't anticipate is we have 10-gallon and 50-gallon water meters out there. In other words, they don't turn the dial until you've used 10 or 50 gallons. So what this creates is the water charts are a little less granular than the electric charts, but it has still turned out to be a valuable tool for customers and also a valuable tool for us to become more proactive in what we're doing. The other aspect of our project has been demand response. We are in the midst of deployment of smart thermostats to our community. The city has had a demand response program since 1982 where we installed devices to cycle electric hot water heaters off during peak periods. In the 2000s, we also started cycling air conditioning units. So this is a continuation of a program for us with much more sophisticated technology. Basically what we're doing is, because there's a value in peak reduction for us, we are giving the thermostat to our customers. But we also realize that our customers really are going to interact with us more and more on a mobile basis. So currently we have deployed our web portal data actually I shouldn't say we've deployed. In exactly 6 days we will be deploying our web portal to mobile devices, and also our programmable thermostats can be controlled through your mobile device. And we really see this evolving in the future so that more and more of our information is available via a mobile platform, because I'm sure you, like myself, more and more are doing business on my phone than I am at my PC at home. So where we're at today is really all of our meters, the communication system is functioning successfully. We're billing all of our customers. We have certainly gone through a lot of troubleshooting and working to ensure that our billing is accurate, and we're continue to monitor and to correct anything that we find. Our web portal is active and mobile launches in about a week, and our demand response deployment is underway and going very, very well. That and remote switches have been deployed as of a few days ago. We are now have the opportunity to connect and disconnect our customers. So we've realized a lot of benefits from this project, both internal operationally, but also with our customers and the information we provide. To give you an example of one of the operational benefits that we've achieved is we've really started to gain the ability to be much more proactive in what we do. This is a screenshot of some low voltage alarms that the meters are giving us. And we started to see an area that was flagging up for us. We were getting quite a few alarms. So we moved forward to map those into a specific area. And as we moved forward to map that, what we discovered is we were getting these low voltage alarms related to a single transformer in a given area. So what this indicated to us is we had a transformer that was being overloaded and could be on the verge of failure. This gave us the ability to really be proactive, to get out there, schedule an outage, change this transformer, provide notice to the customers what was happening, because as you all know, inevitably this transformer was going to fail at midnight on a Friday night, just to ensure it was totally inconvenient for everybody. For our customers and their ability to make those informed decisions, showing you some of the tools that we have, but some great examples of some of what we've been able to do is related to water. We check the flags on a daily basis and have been able to identify water leaks that some of our customers are having. We see in the future the ability to offer information to customers. They can monitor their use. It's not uncommon here for pipes to freeze, and there have certainly been instances where basements have filled up with water and then frozen full of water or full of ice. And we see this as an opportunity for our customers to be able to catch those things, whether they're home or not, before they become significant or worse issues. Customer expectations. We really hope that what we can do is provide information and access to customers so that they don't necessarily have to make a phone call to us, but it's all at their fingertips on a web portal. All that information is just readily available to them, and we think that is what they want and a better service for them. And to date, just to share some statistics with our web portal, we've got 3,342 unique users, 6,900 sessions, which means we're getting repeat visits, which is very encouraging. And what we're seeing, we're just rolling out the marketing campaign, letting customers know that this is available. We're seeing about 200 additional customers, unique users, on a weekly basis. So this continues to grow for us. So the results. I spoke earlier to the fact that we anticipated some benefits with our system. We are just at the beginning stages of starting to realize those benefits. Meter accuracy is a significant one. We originally anticipated that we would see about a 0.5%, 0.25% gain in accuracy. We're actually seeing close to 0.8% accuracy gain in our meters, which is a significant difference, and will hopefully accelerate our return on our investment. Reduce meter reading expenses. Certainly, we have no longer have the meter reading staff that we did. One of the things I wanted to comment on, because that's certainly one of the most difficult things about a project like this, is the fact that you're reducing staff. But this is a long enough term project, we were able to give our meter readers fair warning, to provide opportunities for them in our education programs and to really expand the education programs that the city offers, and provide them opportunities. As our meter readers left, what we did is backfill them with what we call hourly employees. These are typically short-term contractual type employees. Each of those employees, as they came in, knew that we were replacing our meters, that the job would eventually disappear. I feel very good in the fact that all of our longer-term meter readers that had been working with the city for a long time have actually been able to find other jobs, be it with the city or someplace else. I always share the story about the first gentleman that took up an opportunity and asked us to help him pass his CDL driver's test. So we spent some time helping him, teaching him how to drive a big truck, and he achieved his CDL and promptly moved to Florida to become a truck driver. But for us, that was a success story. We had helped advance his career, and that was certainly our hope for all of our meter readers. We also anticipated some benefit from detecting water and electric theft, diversion from our system. This is a benefit that we have not seen realize. We did discover a couple of diversion points on our system, but not to the level I think we had anticipated, about 0.25% of theft out there, and we saw nowhere near that, which is encouraging. Engineering benefits, we certainly have seen, as I shared, the ability to be more proactive on how our system's operating, and we continue to advance how we are analyzing our data and how we're looking at it, utilizing GIS capability to take a look at where flags are occurring, and then to trend that as well. Cash flow advances, a little bit too early to have be able to put a real value to that, but we know we are realizing those benefits, along with being able to reduce the number of billing periods that we do have. Anticipated annual costs, software maintenance and support actually came in a little bit higher than we originally anticipated, not too far off. We did have to add more than the single full-time employee that we anticipated. We have added 2.5 employees to support the system. One is a half-time employee that is helping with the cybersecurity and those policy components. The other is a business systems support analyst to help ensure that the physical systems and the software systems are all running appropriately, along with that database administrator. So with that, I'd like to say thank you all very much, and we are open for questions, so I'll turn it back over to you, Paul.
Well, thanks so much, Steve. That was very interesting. You covered this project soup to nuts, including the personnel issues, and I thought that was fascinating. That you've really given this a lot of thought, and obviously we at T&D World think it's an excellent program, and have certainly looked at it from a lot of angles and gotten a lot of good comments. In fact, today we got a lot of questions, so let me hop right into that. I've got a question here from Peter, and he wants to know: was the ROI of 11 years, was that based on the 32 million, or was it minus the DOE grant?
That was minus the DOE grant. And to expand on that a little bit, the original project we proposed to City Council, where we were just going to do metering, we anticipated that to be about I think it was a $21 million project. And that had, interestingly enough, a very similar payback. As we expanded the project, though, to include things like grid automation plus an MDM, the cost, of course, went up, but with the DOE's help, we were able to reduce that cost to $16 million.
Okay. Another question from Bashar. For the 1 read per day option, is the meter still recording 15 minutes or hourly readings?
No. And that was one of the biggest challenges. We committed to our customers that we would not store any data about their usage. And in our interpretation, what that meant is we would not record it at the meter. We could have considered bringing all the data in as if it was a normal meter read and deleting that data, but we didn't think that was true to the spirit of our commitment to the customers. So we worked quite extensively with Elster to figure out how to program a meter to do just that 1 read per day.
Okay. Thank you. And a question from Tom. What percentage of your customers participate in the time of use rate structures?
We currently don't have a time of use rate structure. We are going in front of our city council in January to propose a program. Basically, we would start with a pilot program and then understand the impact and the usage patterns that this creates with our customers, and then move forward from there.
Okay.
We do currently, though, have a tiered billing system.
And Tom might ask on that too. What percentage of your customers participate in that?
That's all of our residential customers are on a tiered rate.
Okay. Question from Paul. Are you working with technology folks at Colorado State University at Fort Collins?
We certainly have worked with them as they look at a metering system as well for recording their building usage. But I think one of the areas of most significance is Colorado State is home to the used to be the Engines and Energy Lab. Now it's called the Powerhouse, which is the largest engines lab in the country. And we work with them very, very closely. We have proposed several programs with them, such as how do we go about sharing the information we're learning, the large volumes of data, with a research community, how to go about setting that up. And we have a couple of proposals that we would like to see move forward, where we would not necessarily aggregate the data, but take away any personal information that could be derived from the data, yet be able to share with researchers how customers are using energy. So we're very proud of the fact we work very closely with CSU. Okay.
And Tom asks, how secure is the meter customers' meter data?
As we kicked off the cybersecurity program, part of the evaluation you do is a risk analysis. So both the risk of intercepting the data and the value of the data was deemed to be low and low. But that being said, we do encrypt all of the communications from the meter to our gatekeepers, where it's re-encrypted to move forward on our Wi-Fi network, and as it's brought back on our fiber network to the city. So we actually have done some penetration testing, hired an independent firm to evaluate our cybersecurity, and did very well at that. I'm not going to say we passed it perfectly, but our issues were people issues, not technology issues.
Okay. All right. Alex asks, who pays for demand response and controlling air conditioning?
Not clear on the question, but we, as far as who pays for it, there's a benefit to the city in controlling our demand because we're billed on demand as well. So what we have done historically is provide an incentive for customers that were on the hot water heater program. I believe we had an incentive of $5 per month for the air conditioning program. I think it was $10 for the 3 summer months. And that's covered by the utility because overall there's a higher benefit to the utility for that.
Okay. And I just mentioned here too that you are you're a city utility, so you don't operate quite on the same rate base regulations that, say, a investor-owned utility would operate on. So it's a little different the way you account for it.
Correct.
Yeah. Okay. Let's see. Boy, we're getting a lot of questions here. Hold on. Page through them. Okay. Here's one from Michelle. Are you doing connects, disconnects, and double orders, name changes, remotely?
Not familiar with double orders or name changes, but we have just kicked off doing connects and disconnects remotely, and it is turning out to be very successful and a significant benefit to our business case. Our practice has been for every move out, we typically go and we disconnect. And as a university town, we have a huge transient population with the students. So the ability to take care of this without having to send a truck out to take action is really starting to help the bottom line of this project. Okay.
Question from John. Have you been able to take advantage of the outage management benefits of AMI yet?
We are just starting to explore that. You know, the meters give a last gasp that they're out of power. We have a system that is home built that we are planning on integrating that into to provide additional information. That's actually part of my project initiatives in 2015. One of the things we have tried, though, is after restoration on an outage is pinging all of those meters to confirm that power has been restored. As all of you utility folks know, every once in a while you restore power in a given area, but there may be a customer with a unique issue and they may be off and you don't know it. So we found that to be a great test and hopefully something we can continue to expand on in the future.
Okay. Question from Michelle. Do you roll a truck immediately when you get an alarm in EAMS, or do you research an alarm before rolling a truck?
Typically, it depends certainly on what the alarm is, but we'll try and do some research on it. If it's a flag, low voltage, or some condition like that, we start to look for patterns and plot those patterns out on the GIS. Certainly, if we have a meter that is not reporting for several days, that could be dead or malfunctioning, then we'll roll a truck out as well.
Okay. And a question from Jorge. Can the AMI pinpoint the exact location of an outage?
The AMI itself can't. What it will do as we, in the future, start to integrate it into our outage management system is much like what happens today. Today we have customers that call in. We may get 6 or 7 customers that will call in a neighborhood, and from those locations that you can then apply some logic to say, well, this looks like the transformer feeding those customers, or this looks like the upstream protective device, or this looks like a switch, or you can utilize where you're getting calls from to better pinpoint where the line crews should look for a problem.
Okay. And a question from Chris. Are you metering your distribution transformers?
No, we're not.
Okay. And a question from Trung. Is the AMI system treated as critical infrastructure? If so, do the assets include equipment all the way down to the meters?
I'm not clear on what that question is.
I'm just guessing myself that it has to do with the security protocols for critical infrastructure,
okay.
But I don't know.
If that's the case, as a distribution utility, we don't fall under those requirements. We actually, as we looked at CIP, discovered that NIST 800-53 standard cybersecurity standards were much more applicable to our role as a distribution utility.
Okay. And a question, and Trung, you can write back in if that's not your question. You can re-ask, but I think that's probably it. Question from Jacob. What type of changes did you see related to meter serviceman maintenance, and specifically, are there ongoing communication issues on a daily basis?
I'll address a couple of elements, not necessarily service maintenance, that we found, and that was the time to install a water meter plus a module did increase that installation time. Related to maintenance, certainly we have seen as we did our initial deployment, you have some infant mortality, so our meter exchange did go up. I mean, we just replaced 100,000 meters within the community, but we're starting to see that calm down. And as far as the communication issues go on a daily basis, as I noted, the system is operating very, very well. We are seeing in our statistics 99% delivery on a daily basis of the meter data. What happens is if a meter doesn't deliver in that particular cycle or that particular day, the meters have memory in them multiple days, up to 45 days of memory over the. So if you have an unsuccessful read or increment there, it'll try again to fill it in the next day. So if you have a gap in your 15-minute data, the next day it works to pick those up. And then if that gap continues or there's just a hole in the data, the meter data management system performs verification, error checking, and editing, VEE, which helps resolve any of those data issues that you may have.
Okay. Question from Michael. Do you utilize AMI data in the operation room to monitor network status using modeling software?
Not yet. What we hope to achieve is that we can take our AMI data and pass that on to our modeling software so that we can have true data of how our system is operating.
Okay. And a question from Tricia, and she asks, approximately how many service connections are there? She's trying to understand the number of customers using the customer portal.
We have have approximately 68,000, I don't have the exact number in front of me, 68,000 customers out there. Some are electric and water, some are just water.
Mm-hmm.
The vast majority of them are electric and water.
Okay. And all of those would be eligible for the customer portal?
Yes. Well, let me clarify. Our small commercial and our residential customers will utilize this portal. We are still working to deploy a large customer portal.
Okay. Fred asks, could you talk a little about the need for wireless collector sites to communicate with the mesh meters?
I believe what he's talking about is our collectors. A collector will connect to the mesh, and it's a central collection point that then ties to our wireless radios that are across the city. And the wireless radios are also a mesh network, which then 1 out of every 10 of those connects to our fiber optic system to bring data back.
Okay.
And Mike might want to jump in. I don't, off the top of my head, know the number of meters each gatekeeper will communicate with.
Yeah, this is Mike. The average numbers in the 12 to 1500 range, they max out about, the current ones that you guys are using at Fort Collins max out about 2,000 points for electric and another 2,000 points for water for about a total of 4,000 for each box.
Thanks,
okay.
Mike.
Question from Mark. Did Fort Collins already have an existing water meter change-out program in place? And if so, what was the average age of existing meters?
Yes, we certainly have a water exchange or water meter change-out program. I believe the replacement cycle varies a little bit depending on the type of customer, but on average, I think it's 7 to 9 years that they anticipate having to exchange those meters.
Okay. And a question from Michelle. How many industrial customers, three-phase customers, do you have on the smart meter program?
We have all of them except for, I believe there are 18 customers or so, our very largest industrial customers that we have not transitioned yet.
Okay.
But certainly we break our classes up into 50 kVA and above, all the way to 750 kVA. 750 kVA is considered a large industrial customer, and I think we only have 18 of those.
Okay. How's your voice holding up? We had a lot of questions for you. We still got a lot more to go. Well, but we'll get through them as fast as we can. Okay, Peter writes, do you expect electric usage to decrease as users have the ability to monitor their data?
We certainly hope so. And that is part of the analysis we'll be doing over time, is to see what effect we have had on that by providing better information. And I will note our web portal, one of the features that it has is you can set alarms or alerts that you'll either get an email or a text message. You can set a budget fundamentally, and it'll make you aware that you have hit the budget and there's still time in the billing period, which we hope helps customers learn how they use energy and then start to manage it.
Okay. Alex writes, what is the life expectation of the AMI asset considering an 11-year payback?
We anticipate that we will have at a minimum a 20-year life from the meters. As with all electric utility assets, it'll be more, we hope, but as we did our business case, we looked at a 20-year life.
Okay. And I think you touched on this before, but Diane asks, how is the web portal information kept secure?
You have to log in. It is paired with it's a single sign-on feature that is paired with our online bill paying service. So I can't get into the deep details, but basically each customer has to log in just to their account.
Okay. Bill asks, does the water and electric meters use the same communication network, or do they have different channels?
They use the same communication network. Actually, the water modules, because they're much lower power, they're battery, served by a battery, speak to pair up with an electric meter or a repeater to come back to the gatekeeper.
Okay.
So basically the water meter data passes through the electric meter and is sent on to the gatekeeper.
Okay. Chris asks, can you explain what grid automation features you have deployed or anticipate deploying? We
focused on automated switching on our system so that we could reconfigure our main feeder system during a outage or even for switching operations. We only are doing a very small number, about half a dozen of those. One of the concerns we had is that's a cultural change for our line crews, so we wanted to introduce a technology. Pleased to report they're getting very, very comfortable with having somebody in a room somewhere control the switches that energize the system, and we do anticipate doing more in the future.
Okay. Pat says, sounds like service disconnect feature was not considered as a savings in calculating the business case payback.
It was, but at a very low dollar value.
Mm-hmm.
And what we're finding is it is much more usable than anticipated.
Okay. Does the cost of the AMI system include the city Wi-Fi and fiber backhaul required for the gateways? And that's a question from Peter.
Yes, it did. It included the connection from our existing fiber network to the gateways or to the gatekeepers, our Wi-Fi network. The city has a fairly extensive fiber network for traffic lights, for our substations, and different purposes. So we just had to extend from key locations over to those Wi-Fi points.
Okay. And here's a question from Bill that I've heard a lot of times. It says, without meter readers visiting every cycle, how often are service meter installations inspected?
We anticipated that, and in the original business case, and what we're doing today is keeping one meter reader on board. Plus, we have those manual read customers that we still have to serve, with the intent that that meter reader would visit every site once a year and provide an inspection.
Okay. Okay, here's a question from Glenn. When it comes to water meters, what is the make and model? Question. Are the water meters installed indoors or outside above ground or outside in pit sets? Do the water meters mesh with other water meters or other electric meters?
The make and model, I would have to go ask our water meter guys. I know we have several different manufacturers that we utilize there. Installation-wise, we have some of our water meters are in pits outside of the home. Others are in the basement with a remote reading point outside on the wall that is where we put the communication modules. And others, we had to actually install the communication modules in the basement next to the meter. So we had basically 3 different types of installations to deal with. And as you can imagine, the most inconvenient, of course, was having to get into a customer's basement and install something there.
Okay.
And as far as do they mesh with other water meters, no, they only mesh with the electric meters or communicate with an electric meter.
Okay. And the question from Michelle, how did the smart meters change the way you work storm restoration? That's a big question in Colorado, isn't it?
Well, for many. We are blessed with a 99% underground system in Fort Collins. In 1962, our city council directed that all new installations should be underground. And then we came back around, and those existing overhead systems we had, we replaced. And so we're about 99% underground. And as a result of that, we have just an amazing reliability number. Our average system availability index for our best year ever, which happened to be 2013, was 99.9982%. Our system average interruption duration index, I'm speaking to a lot of utility people, I hope, is right around 11 minutes.
Okay, well, we're at the top of the hour, and we told everybody this would last an hour, and we still have questions to go. So we're going to hang in here for a few more minutes, but we just want to let people know that we're not going to be here indefinitely. We're going to wrap this up in, say, 5 minutes, but we do have more questions. So proceeding on here, question from Alex. Well, see, let me go down. We answered that one. From a name that's not spelled out, you said something about disconnecting devices and the customer. What was that about?
Let me see if I can, if you would mind rereading that to me.
Sure. It says you said something about disconnecting devices and the customer. I think he's just asking about the conversation about disconnecting customers. What was that about?
Oh, as far as our disconnect ability in the meter?
I think so. I think that's what he means.
Certainly, as we have move-ins and move-outs, we will disconnect the meter, de-energize the home or the apartment. We also certainly have customers that on occasion are disconnected for non-payment. What this does is give us the ability to do that remotely rather than sending individual out to manually operate that switch.
Okay. Bill asks, have you employed an outage data management system? I think we touched on that.
Yeah. We do have one. We have not yet integrated it with the AMI system, though.
The AMI is the first step in putting together the infrastructure that allows you to do a lot of things like that.
It as I noted, it's very foundational to the future for us.
Yeah. Okay, let's see. Pat asks, were there any customers that wanted their data more often than once per day?
Certainly, we provide actually 15-minute data is our normal installation. The once per day is an option for those customers that are concerned with data privacy. As far as how often the web portal updates, that is happening on a 4 to 6 hour cycle or so.
Okay. Right.
And I will add, there are also, the meters we installed have Zigbee communication in them as well, and there are devices out there that the customer can buy that we've been looking at how to pair up with the Zigbee that will provide them unverified data off of the meter about every 8 seconds.
Okay. Question from Cyrus. What is your average RMA rate on the new meters?
We'll leave that to the next webinar that we're having where some of our subject matter experts will be able to tell you exactly what that number is.
Great. And just a reminder to our listeners, too, that this is the beginning. Today's, which although it was very thorough and went in a lot of depth, there's going to be a lot more depth in the next 3 seminars coming. Cyrus asks Cyrus again, are you on EAMS 9?
No. I think
Okay.
we are moving to that, excuse me, at the beginning of next year.
Okay. And I'm paging through. We still have a lot of questions, but we're going to cut them off here in a bit. Here's a question from Brian. Do you recommend all utilities make this move from analog to digital meters? Why or why not?
I think that's up to the individual utilities to take a look at their situation. We decided not to leave any analog meters on our system just because that was part of our oldest infrastructure. Mm-hmm. If we were going to go out there and visit every location, it was time to upgrade them all to digital, whether they have communication in them or not.
Okay. And by the way, I just want to tell everybody, we're having more and more questions come in. So I said 5 minutes a while ago. We're probably going to hang on here a little bit longer. If you need to leave, just leave. It's fine, but people are still interested in sending in questions. So you're a popular guy, Steve. So as long as your voice hangs in, we can go a little longer. If that's okay with you.
Yep. Couple more minutes is fine.
Okay. Here's a question from Everett. What level of problems, tech support, detective units, etc., have customers reported regarding programmable thermostats? Also, any conflicts with customers who want to use their own thermostat?
I'm going to take the second half of that question first. Part of our Phase 3 deployment is support of third-party thermostats, such as Nest and the others that are out there. And so that's our intent, and we are actually moving forward with that. As far as what levels of problems, certainly we did a small friends and family deployment initially with the thermostats. So we were able to spend some time and take a look at what issues may come about. Found some strange things such as daylight savings time, I believe, was an issue, or time itself. So we have had some issues, but I believe now all of them have been resolved. As far as customers' issues, I'd have to go digging for those statistics. But one of the things we're doing is we are installing the thermostats for the customers, which ensures that they're working at least as the installer leaves.
Well, Steve, thank you so much, and we're going to give out before your voice gives out. You've done a great job. We've left a lot of questions unanswered, but that's good because people can come back next time. There's going to be the opportunities to ask them again, and we'll have more in-depth technical details, although you certainly went into a lot of depth. So, folks, don't miss the upcoming webinars in this series, and they're going to get into a lot more of the technical details of the Advanced Meter Fort Collins project. The next webinar, to be held on January 8th, will look at the technologies that Fort Collins uses for the AMI deployment. Now, you can register for all of the webinars on tdworld.com/AMFC. And on behalf of T&D World, have a productive remainder of the day.